Welcome everyone. I think we're live right now. Let me verify that is the case. Can you still hear me, Pablo?
Yes.
Cool. All right. Yeah, should be live now. Yeah, we're live. We're live on LinkedIn, on YouTube. So yeah, if you're just joining us right now, let us know in the comments where you joining from. I'm in Colombia. Pablo is in the US. Uh, we both speak Spanish, which is a hard to find coincidence. So if you speak Spanish, welcome to do so. I'll drop here a comment so you can see at any point in time during the presentation, no matter where you're watching, you can ask questions in the chat, and we'll have a section after the demos to cover all questions. So feel free to ask them anytime. Great. So if it's your first time here, probably you're wondering what's Union. What what is this? Union is the main contributor to Flight, the open source project. Flight is a Linux Foundation project that was born out of Lyft, like I don't know, 7 years ago or more, and it was donated to Linux Foundation, and it has evolved to be a very robust, performant, scalable, um, let's say, system to build AI applications in using similar patterns as you will expect for software engineering apps. Some may know Flight as a workflow orchestrator, and it's also a workflow orchestrator, but it's probably way more than that. And this event is essentially a way for us to start to kick off the discussion around an idea that we think is very interesting, which is compound AI systems. So yeah, if you have questions after the session, or if you want to know more, you can also go. Let me see if it's here. Yeah, you can also join the Slack community. Um, we are all there. All the maintainers of Light are there. Even the original creators of Light are there, still answering questions years after the creation of the project. They are still there. So that's pretty interesting. All right. So yeah, let me start real quick here with a little thing I wanted to share. How this works, and it's here. Yeah, I'll try and share my screen. Yeah, share screen. There you go. Cool. Yeah, Pablo, can you see the screen?
Yep.
Cool. Awesome. Thank you. So compound AI systems, I will drop the link in the comments. The idea is not ours. The idea came from the Berkeley AI research group. And in a nutshell, it's kind of introducing the idea that models are not enough, especially to produce significant outcomes. Model size and model performance in isolation is not enough. So, brief summary that I brought here for the is that essentially you need the vision here is that systems are more than models, right? To really produce groundbreaking results, it's not only about the quality of the model, but building a complete system that can aid the model and adjust it and improve it for specific use cases, and then it can produce significant outcomes. So that's the whole system design perspective. And really, if you don't read the article, it's fine, because in a nutshell, an compound AI system, it's the combination of traditional software system plus AI models, right? So they make bold statements like an AI model is just a transformer or a statistical predictor, and that's it. On its own, it kind of achieve a lot, right? You need to add other components to make it achieve something significant. And there are many implementation of this. Let's say RAG, retrieval augmented generation, which seems to be all the rage. Only before the introduction of DeepSeek and reinforcement learning and etc. But all of them are implementation of the same idea. The model itself is not enough. You need to add, for example, a retriever, a system that goes and let's say expands the data set, the knowledge that the model has, and goes and retrieves knowledge from other models or other systems from browsing the internet, right? So these are all implementations of the same idea: software or multiple components plus AI models. Some may call this agentic AI, right? And in our opinion, agentic AI is an implementation of this idea. But this is a broader perspective, bringing system design into the AI world to produce significant outcomes. There's a lot of challenges and none of them are solved, right? That's the other outcome of the article. Probably some of these challenges are already known to you. There's a lot of tools, ever growing ecosystem. Probably a new open source project is released every day to solve a particular area in the AI, in an AI system, right? How to combine them. And the second challenge is related: how to optimize your model for a specific tool and how to optimize that tool for your specific model. That's another challenge. And of course, because if it's a complex system, it's hard to monitor, right? It's not easy to understand where and what should I observe to really determine if the quality of the model is improving or not, or the quality of the app. And also because there is a lot of data involved in this, and heterogeneous data sources and heterogeneous systems producing different types of data. What the article calls data ops is essentially having a robust data flow system that manage all the data movement between all these different components. And of course, it's a complex system. It's hard to secure and it's hard to ensure compliance. And how to optimize, and probably a step before optimize cost, is be able to visualize, to have a clear view or where the money or where the resource or a budget is being spent in a particular area of the system, and then how to optimize it, right? The article mentioned ideas like the routers, the AI routers that can determine the best foundational model for a specific request, and then probably do it in a way that saves cost. And finally, the goal is to maximize quality and reliability of the AI applications. So that's in a nutshell compound AI systems. Again, I will drop the article in the comment section so you can read it on your own, but this is the idea. So with that, I'll stop sharing and we can move to something probably even more interesting with Pablo. There you go, Pablo.
Okay. All right. Thanks, David. Let me share my screen now. Let me know when you can see my slides here.
There is. I can see it.
Okay. All right. So thanks, everybody, for joining. My name is Pablo. I am a solutions architect here at Union. And I'm going to walk through how you can use Union to build a platform for integrating and putting together all of your AI workflows. I realize that some people here may not know what Union or Flight is, so and some other people may be very familiar with Flight already. So I'm going to try to strike a balance between giving everybody enough background onto what this is, while also pointing out for the more advanced Flight users what is specific to Union, what is specific to Flight, and what are some of the things that can be done in Union that can't be done in Flight. Okay, so if you're in this webinar, you probably already know this, what we're seeing in this slide here. All the different pieces and all the different moving pieces and components and things that need to be integrated in order for you to build a system end to end. Like David was saying, it's not just about the model. It's about all these different things, whether it's feeding data into the model, whether it's operating the model, whether it's figuring out when you need to retrain the model and all those things. That's what we're going to walk through. And the demo that I have is based on a very simple binary classifier workflow. So it's as simple as possible so that I can kind of show what these concepts are and how they all fit together. So what we're seeing people use Union for is for connecting all those boxes really well, and also for doing compute on some of those things. So what we have here is a reference architecture of what can be built in Union. And if we go from left to right, we have the data scientists, or the people who are working on these models, the people who are analyzing data. We really want to meet them where they're at. So to that end, and as some of you already know, we have SDKs that you can use inside of VS Code as you're doing your models. So data scientists can really interact with the platform in that way, in environments that they're already familiar with. This also applies to running in notebooks. It also applies to a concept called workspaces that we have in Union that basically brings the notebook experience inside of the platform. So you can still use the same tools that you have that you're comfortable and familiar with, but now you have very easy access to this almost infinite backend that may be running on your cloud, whether it's AWS, GCP, or whatever it is. And then as I'll go through in the demo, I'll show you how using our artifacts functionality as the glue between all these different pieces of these workflows, and the glue of how you can have this platform do more automations for you to take, let's say, the outputs that the data scientists do, whether it's data sets, whether it's code, whether it's trained models that are ready for production, and how they can register those things as artifacts inside of the platform. And then the platform can just take those things via something we call reactive workflows, which are basically workflows that get triggered when an artifact gets created, that can go on and do all kinds of automated stuff, like evaluating your models, visualizing your model's performance, doing data exploration, all automatically based on artifacts that your end users or your data scientists are submitting to the platform. And then, of course, part of those automations can be, let's register these results to our experiment tracking system if you want, like MLflow, weights and biases, or send some notifications to the end user, the data scientist, like, hey, your automation is ready, or your model has been launched to production, whatever it is that you've automated. All these things can be put together and connected with the Union platform. All right. So I'm going to keep going here, and I'm going to start on the left-hand side of this screen. So I'm going to start where
Pablo, could you zoom a little bit?
Yeah.
VS Code, like 1 or 2 points.
Yep. Let's see. Zoom in. How's that?
Yeah, that's better.
I can zoom in a little more if you
let us
want.
know in the chat if it's not better.
All right.
No, thank you.
Okay, perfect. So I'm going to start where your users are, and let's make this smaller. So what I'm going to do, and this is a little bit of background, I apologize to people who already know Flight relatively well. How we do this is just almost like regular Python code. So you as the user are writing code, or you can take your code that you already have existing, or you can take pieces of a workflow, whether it's shell scripts or whether it's pulling data from Snowflake or whatever it is. You can bring these things into the platform in different ways. I'm going to concentrate on just Python code, but just know that you can bring in all kinds of different components into the platform to automate. So this looks just like Python code, where we have, and I'm going to get some data from Hugging Face. I'm going to featurize it. I'm going to create basically a very simple grid of the hyperparameters I'm going to optimize against. I'm going to do that optimization, and then I'm going to choose the best model, which is down here. And then I'm going to register that model as an artifact inside of the platform. So very, very simple workflow on how go from data to model and hyperparameter optimize that model. What you'll see here scattered inside of this code and how really you bring code into the platform is you'll see these decorators, and you'll see a lot of these different kind of configurations for them. So this method here has been decorated with a union.workflow, which basically tells the platform, hey, this code is a workflow, so treat it as such, and we'll see what that means fairly shortly when we get into the UI. And then, of course, we have, inside of these, we have tasks that we're calling. So if we look at, let's say, the get data task, it's the same thing. We have a little piece of Python code that goes out and gets data from Hugging Face, and it's decorated with a task decorator. So this task decorator can have a whole bunch of different stuff in it, configuration, whether it's what kind of container image to use. And this contains things like all the dependencies, the registry where it's coming from, all that kind of stuff. And here you can put in whether you want to cache the inputs and outputs of this task, whether you want to request specific resources like a GPU or a fraction of a GPU, or X number of cores and things like that. Those are all defined within the code here, so that you as a data scientist can have all your stuff together here, all your workflow definition and all its dependencies and all of its configuration, it's in one place. And then the platform handles all the infrastructure handling and all that by itself. It takes care of all that automatically to provide all the configuration and all the resources that you're asking for inside of your Python code. All right, so when I run this workflow, the platform automatically kind of takes everything together, figures out all the tasks that are part of this workflow, puts all your configurations together, and basically runs it like you want it to run in the way and the requirements that you gave it to run. All right. So before I run this, I just also want to mention very quickly that one of the great strengths of Flight and Union is that we have parity between running these workflows locally on your laptop and running them out on the cloud. And so they are guaranteed to run the exact same way, so that the code that you're developing, if it runs on your laptop, it'll run when you push it out to the remote, to the cloud. So in a way, this code is, once you get it working on your laptop, it's basically production ready already. It is ready to get pushed out to remote, and it'll run exactly the same way, just in a much bigger environment that you can scale out from. So the way that we do that, or one of the ways that you do to run this code, is if you look down here, I'll zoom in on that specifically. If you look down here on my terminal, I am now doing a union run. I'm going to constrain this workflow to run with a maximum of three parallel processes, and we'll see why that's important later. And then I tell it, my workflow is in this file, and the name of my workflow is Pablo_WF, which is basically the name of this method that I've decorated with the workflow decorator. And if I click on that, or if I run the command, it's basically running all my stuff locally. So you can see a whole bunch of output come out as it's training my models, it's doing my hyperparameter optimization, all that stuff. At the end, it actually goes out with an error, which is on purpose, which is a task that is meant to fail. So everything is run locally on my laptop. I've tested it. I see that everything is correct. It's doing what I expect it to be doing. And I'm now ready to push it out to my remote cloud, or I'm ready to push this out to production even. all I need to do is go into the same command that I had before and just add a dash remote flag to it. And once I do that, what's happening is the platform is grabbing all my code, all the stuff that I've written. It's grabbing all the requirements in terms of like all the dependencies of all my tasks. It's putting together a graph of what the workflow looks like, which tasks need to get called at what time, and with what data dependencies. And it's packaging all that up. It's sending it up to my cloud, and it's going to run it inside of my cloud account. And I can go directly into my UI by clicking on that link that it gives me. And now I can see what my workflow is doing as it's running in my cloud account, and as it's using some of the resources out there. All right, so, and just to give some more background on what's happening here, Flight and Union are basically run on top of a Kubernetes instance, whether it's local or whether it's the AWS Kubernetes service or the GCP Kubernetes service. It doesn't matter. We basically can take over a cluster. We can orchestrate all these things inside of it, and we can scale it out as much as the cluster will allow. So what happens is we've automatically figured out, by looking at the code that I wrote and that I was showing everybody, all the different tasks that are part of this workflow. It's actually even figured out what the graph looks like. So based on the dependencies of the data, of the return values of these tasks, of the parameters that are being sent to downstream tasks, it figures out which ones are dependent on each other and which ones need to run in series and which ones can be run in parallel. So it figures out this graph automatically. It packages it all up. Each one of these tasks will run in its own pod or its own container. And it also handles automatically the passage of data between one task to the other. So you can see that the featureized task spits out a data frame, and the data frame gets fed into the hyperparameter optimization task. All those things are handled automatically. And what you can see here as well is that the hyperparameter task or the optimization of the hyperparameters is actually been parallelized. So there's about 9 or 10 different combinations of that grid search that I put into my workflow, and the platform takes these and runs them in parallel to basically take as much of take the resources that I've told it are available to it to make this run faster. So in this way, the platform, Flight and Union, both give you a very simple interface into how to massively scale out and how to achieve mass parallel compute on your cloud, on the platform, without you having to worry too much more about how do I implement it, how do I pass data back and forth, these dozens, hundreds, or thousands of parallel processes. How do I do all that stuff? It's very easy to do inside of the platform, and it's all part of how you create these workflows. And we have several different constructs on how to do that. Okay. One of the things that I want to point out here that is specific to Union and not Flight is what we call a feature we call actors. And actors are, I mentioned that all these tasks run in their own containers. So you can see that the get data task runs in its own container. It takes a little while for the container to come up and for things to start running. Same thing with the featureized tasks down here. This concept of actors is a way for us to reuse your infrastructure in a very efficient way. So if you remember, I put in a max parallelism of 3. And what that means is basically constraining constraining these parallel processes to run 3 at a time. Of course, like we have customers who run thousands of parallel processes at the same time. So 3 is a very small number, but it's really just for purposes of the demo here. So as I start fanning out my hyperparameter optimization task here, I see that I have 3 that kick off at the same time. They take about 10, 7, 12 seconds, the first 3. And then you'll notice that the next round of them, which is about 6 or 7 more of them, you can't even see how fast they ran. And that's because of this actors concept of this, or this actors feature. Basically what that means is that we have a max parallelism of 3. I'm going to spin up 3 containers for this particular parallel process, which is doing the optimization. And then those 3 containers are going to stick around, and then I'm just going to reuse them. So the platform has these 3 containers that are still running. When that one process is done, I'm just going to feed another one right into it. When that's done, I'm going to feed another one. So it's reusing these containers. It's reusing your infrastructure, doing this very efficiently and giving you complete abstraction over all that, right? So you can get all these benefits without necessarily having to know or care about what the infrastructure underneath your code is doing. The platform handles all that for you automatically. Okay. Okay. All right. So what I'm going to do here now is talk about some of the automations that can be done from this point on. So at this point, what we've looked at is just the end user's experience, right? Like the data scientist experience, or whichever person is in your organization, running data, training models, and doing that kind of thing. So at the end of this process, of this workflow, we have a task that retrieves the best model from the hyperparameter optimization process. And then we have this one which registers that model and some other stuff about it, some other metadata, pieces of data about it as well. So it's kind of this object that contains the model plus information about it, and it registers it as an artifact inside of the Union platform. And this is also something that's different between Flight and Union. The fact that we've built an artifact registry inside of Union that is not specific to any particular type of object. It's more general use, where basically anything that you can serialize, you can store as an artifact, and then you can query the artifact registry looking for specific things, and you can use them, and you can have all kinds of metadata about them, as well as lineage and things like that. So in this task register artifact, it basically takes the model and some other stuff, and it registers it as an artifact in our registry. And here is a link to that. If you want to use it in some other different code, like if you want to download this model or this bundle with the model plus other stuff, you can do that with this sample code here. Or you can also just click on this guy here, which will take me directly to my artifact registry and the details page of this particular artifact. I don't have too many details on this, but you can put metadata in here, which we refer to as partitions. You can access it from workflows or from outside of the Union runtime as well with this sample code down at the bottom. And the great thing about it is as well, there's some details about what this object is. You can create cards about these objects where you can put in all kinds of information, whether it's charts, whether it's text, whether it's a table. All those things can be put in here so that you can not only keep track of your artifacts, you can attach all kinds of different information for it. And you can also attach all kinds of different metadata for it if you want to do like a search for it next time around. Really, the thing that I want to focus on here, though, is the lineage. So lineage is exactly what it sounds like. It's basically a lineage of, hey, here's my artifact. Here is the workflow that created it, which is the one that we ran about 10 minutes, 15 minutes ago. And there's a new workflow here that was actually triggered by the creation of this specific type of artifact. So I can register this Pablo_model_automation workflow. I can register that workflow to run when a specific type of artifact is created. And that workflow can then take that artifact and do whatever it is it needs to do to that. So if I click on this guy here, it takes me again to the same kind of workflow execution window that we were looking at before, but now we have something that's much simpler, right? And in this case, the type of automation that I've built into the platform is a very simple Streamlit application that allows me as the data scientist or whoever to interact with my model and to tweak my model. And I'll show you what that means in a second. But this can really be anything, right? So I've put in a link here as part of my workflow where my app has been deployed. And I'll open it in a different tab here. Now, this is now relying on some other functionality that's different, that's in Union but not in flight. And this is our serving functionality that's relatively new. So what this means is that now inside of Union, you can deploy just about any application that you can think of. You can and have the Union platform manage all that for you. So in this case, as part of this automation in this model lifecycle, what I've done is just a very simple Streamlit application that allows me to look at the characteristics of my model. Here is the AUC, the recall, all these different metrics on how the model that I just trained performs. Then I have, it's a binary classifier, so I have the confusion matrix, which I find to be the most useful thing for evaluating these, probability distributions. But basically, this is just an app that I built that can be tied or can be made available every single time that somebody submits a model. And this can be part of an automation, right? And of course, since this is a binary classifier, there's always the threshold tuning. So I can change that in this app. I can set it to something else. I can see how it affects the metrics, how it affects the confusion matrix. And then another automation that I built in here as well is I have this button that can deploy this model as part of another application inside of the platform. So once I do that, it'll actually deploy the model, and I can go directly to that just by clicking on the link that shows up. So even though this is a Streamlit application, it kind of runs on the back end of the Union platform, and it can use all the different objects and all the different things in the artifact registry. It can kind of pull on all these things that are made available by the Union platform, and it can create all these different automations for you or for your end users if you're a platform engineer. Okay, so it takes me directly to my application, which is just an API endpoint. So I've now deployed this model to an API endpoint. Obviously, it fails because I'm not sending in any features or any data as input. So let's take a look at the docs page for this endpoint. So if I just add /redoc, this is a fast API application. So it automatically also builds the schema for my API. This is like a lone default data set, lone default model that I built as part of this workflow. So you'll see things like, what is the purpose of the loan? What is the interest rate? The FICO score, blah, blah. So that's the schema of my model. And that is what it's expecting in its features, etc. So this is built for you automatically by Fast API, and it tells you, what kind of things you need to send into the model to get a response. I actually have that set up here, so I'll run that really fast. I have a piece of my data set that I've populated here. I have my endpoint that Union has set up for me automatically when this API endpoint was deployed. And then if I just send this over, might take a second because the application has been killed. So it also these applications also have a time to live. So if they do go down, but a request comes in, the platform will automatically bring it back up. So it comes back up after a couple seconds, and now we have the prediction that this person is going to default on the loan or not. So these are all based on the serving functionality of Union, as well as this concept of reactive workflows, which is what is used to create an automated, an automation or an automated workflow to kick off when you create an artifact in the platform. You can automatically create these things that run, and whether they deploy an application, whether they do something else like evaluate your model, push it out to production, or do a comparison with the current production model, whatever it is that you're trying to do, and whatever components you're trying to glue together, those things are all possible, right? As part of this demo, I made this two very simple applications to describe the possibilities, but it's really up to you what kind of automations and what kind of workflows you can make available to your users. Okay, and the way, just to wrap up what this looks like, the way that applications are defined and created in the Union platform is quite interesting and quite flexible. So if we go back and look at the code, all right, this is my code for my API endpoint, right? And it's, like I said, it's based on Fast API. My other application is based on Streamlit, but it's really flexible in terms of what you can put inside of these apps, what framework, what serving architecture you want to use. It's quite flexible in what you can include inside of them. So I have a Pydantic model that defines what my schema is. Here's some code that may not make sense to you guys right now, but it's basically telling the platform, hey, give me that artifact that I'm using, which is the model plus some other stuff. So this is a code that's pulling the artifact, and then we have just a post, takes the data frame, it featureizes it. It featureizes it with the exact same code that was used to featureize data during training, so you don't have feature drift and problems like that. And then it basically does, from the artifact that it pulled which is this object variable, give me the model, predict the probability with my featureized data frame, and just return it inside of a JSON object. So this is just Fast API code. And if I look at how I wrap this and how I tell Union to deploy this as an application, I have this here. So first off, this is very similar to people who are familiar with Flight. It's very similar on how tasks are executed. It actually looks kind of like an actor in the Union platform. You basically tell it all the same kind of configurations. Like I want it to run on this kind of image. I want it to have these dependencies of packages. I want it to have a GPU. I want it to have 4 cores of CPU, 2 gigs of RAM, whatever it is. You can define all those things. And then Then I have my app definition here, right? I have the name of it. I have the inputs, which is basically the artifact that was created that's getting passed around to these different apps. And I have the arguments of what this app is. So, this is Fast API app, but this could be Streamlit. It could be some other kind of command line that brings up whatever server you want to run inside of this container. And then, of course, I have what files to include and what ports I want the platform to automatically plumb for me. So it takes care of all the plumbing. It spins up a container with my requirements and my dependencies. It puts all my files in there. It automatically takes care of all the plumbing of how the networking is going to go, creates my endpoint for me, and then it starts my server using this command or these arguments. All right. Oh, of course. And here we also have the limits. 1 CPU, 1 gig, but we can also request GPUs, fractions of GPUs, and things like that. And all of that is not contained here. And again, everything underneath, you don't have to worry about. Everything's abstracted. The platform takes care of everything else for you. Okay. All right. I'm going to stop right here. I hope that makes sense. I hope that was useful. And pass it back over to David in case there's any questions or if we want to wrap this up.
Awesome. Thank you, Pablo. That was fast. And I think you covered a lot of stuff. Yeah, probably for everything we saw, there's a bunch of tools, standards, mechanism to same. We just saw it doing it in from a consistent API using an SDK. So I think that's pretty interesting. Yeah, feel free to ask any question in the chat. There are no questions yet, but yeah, I think one of the many challenges here is performance. Yeah, some praise. Yeah, that was a very clear presentation. Thank you.
Thank you.
And we will be covering kind of the title, the name of this session was Unboxing the Architecture. We are just removing kind of the wraps, but we will be truly unboxing this in the coming episodes. We're planning to do this once per month. Let us know if that works. But where we go over a bit deeper on each domain here of this system, there are many fronts here. There is the performance front that we saw very kind of fast, but all the actors idea, why actors, what is the main roadblock right now in executions in Kubernetes, workflow execution in Kubernetes. That will be a separate episode. Monitoring or observability, observing cost, resource utilization, that's a separate episode, and so on and so forth. The idea is also to kind of release the code, right, for anyone to try this. I'm not sure if everything we saw we can, I mean, folks can try it on serverless. Not sure if everything we saw here will work on serverless, which is kind of the free tier. The link you see there to sign up is to sign up for the free tier for serverless. That is intended for a single individual member, not for teams. And it doesn't have all the features. I think, I'm not sure if serving is there available. But in any case, you can also book a demo if what you saw here is fine, but you want to explore something particular to your environment, your use case. You can book a demo, kind of a customized demo. I'm leaving here the link, UnionAI/demo, basically. We can set up this for you. All right. So if no other comment or question, thank you, Pablo. That was great. And yeah, stay tuned for the next episodes as we unbox this. And in any time you can ask questions, you can join the community. I think the link is over here again. You can go there, and we're usually available to help you. All right.
Thank you.
Thank you all. Yeah.
All right. Bye-bye.